So today we're solving. So everything we've learned up until this point with all the formulas, we'll be using to solve. Okay, example 1a. 2 sine x equals 3 plus 2 cosecant x. So what do you think we should do? This is not a proof. This is a solve. Yes, change cosecant to sine. So 2 sine x equals 3 plus 2 times 1 over sine x. Okay, what should we do next? Well, the only problem about dividing by 2 is we have a 3 here, and it's not going to work out so nice. So I don't think I would do that. Well, usually we get the signs on the same side. Okay. Who doesn't like this right here? Yeah, change it back to cosecant, and then we're right where we are. Okay, I don't like a denominator of sine x. So pretend this is a fraction. How do we get rid of denominators? Multiply by what we used to call the magic multiplier. So sine x, we're going to multiply sine x to all three of them. 1, 2, 3. What do we get on the left side then? Yeah, sine squared x equals 3 sine x. And then what happens here? Plus 2. Okay, so now this is a quadratic. What should we do now? Get it all on the same side. So 2 sine squared x minus 3 sine x minus 2 equals 0. And what do we usually try to do first when we're solving a quadratic? Factor. And this one factors beautifully. Don't forget to equal 0 when you factor. Otherwise, that's an error code. And what is this factor to be? 2 sine x and a sine x. The outside would have to be a 2 and a 1, yes? And a plus and a minus, because we need to have a minus 3 there. So that means then what? Sine x equals, what do we get out of the, yeah, negative 1/2 and positive 2. And then at that step, what can we do? No, we should be doing non-permissible values. But before we even do non-permissible value, this is a rejection, right? We cannot have that. And the reason is, yes, but on an exam, if they ever ask you, why are you rejecting this? You don't just say it can't be bigger than 1. Sine x has to be between negative 1 and 1. That's the correct answer that they're looking for. It would be written like this. Sine x is between negative 1 and 1. And you have to have the equal sign because it can equal 1 as well. And same with cosine. I'm sorry? No. Okay, so our non-permissible values, by the way, do you remember what non-permissible values is? That's what x cannot equal. Anytime you have a denominator, which we do in this case right here, that means sine x cannot equal 0. It doesn't ask you to do this. You have to know to do this. Because I might be rejecting something based on that. So that means x cannot equal what? If sine x can't equal 0, what does x cannot equal? Where is sine 0? 0 pi, 2 pi. Okay, so obviously that might not come into play. We probably didn't even have to do that part after that because we knew that none of these equaled 0. So what does x equal then? X doesn't equal negative 1/2. Sine x equals negative 1/2. So where is that? Between 0 and 2 pi, it says. 0 and 2 pi. It is one of the 30s, so pi over 6 is, so which one? 7 pi over 6 and 11 pi over 6. Very good. Okay. That's the part you're not good at. Okay. This one's kind of a goofy one. You could solve this in about basically one line if you understand what it's saying. Where's sine x equal to cos x between 0 and 2 pi? At the 45, yeah.
Yeah, because this is per 4, sorry.
I'm sorry? Pi over 4 and? Yes, 5 pi over 4. Okay, because they're both positive root 2 over 2 here, and they're both negative root 2 over 2 here. So you're saying, okay, that's kind of crazy. There's another way you could have done this. That seems pretty straightforward. If I introduce something harder, you might say, let's just leave it. Okay. You probably would never get this unless it was a 1 mark short answer or multiple choice. Okay. Let's go to this one then.
Baby stuff.
Baby stuff, that's right. Okay, how would we do this one? Tan x equal 2 sine x. Change what? Okay, so this is going to be sine x over cos x equals 2 sine x. Then what? It could be, but I don't. Yes, cross multiply this over. So you get sine x equals 2 sine x cos x. And you might be led to think that's something on your formula sheet, which it is, but I don't know if I would change it. Now what? It just has some trig identities in it. Like when we were solving equations before, you'll see in a second, for instance, the next example, we're going to have to use some trig identities to actually get anywhere. Well, even that one, we're replacing tan with sine over cosine. That's a trig identity we're using now.
So the difference between this and a proof is just like you're actually solving.
We're actually solving. We don't. Yeah. We're getting what x is.
It's like proving that there's
Okay. Okay. So now what do we do? I would definitely do that. Very good. 2 sine x cos x, and that would be minus sine x. Okay. Now what? Never divide by sine x. Why? You could be dividing by 0. Yes. So what's the next step? Very good. Factor out a sine x. We're left with 2 cos x minus 1. Then what? Set the factors equal to 0, which means sine x equals 0. Look, it was equal to 0. We would have divided. Cos x equals 1/2. Okay, so where is sine x equal to 0? Between 0 and 2 pi, it says. 0 pi, 2 pi. Where is cos x equal to positive 1/2? Pi over 6. Nope. Pi over 3. And it's not the same thing. Yeah, it has to be quadrant 4, right? So yes, 5 pi over 3. Very good. Okay, was there any non-permissible values there? Yeah, cos x, so NPV, cos x cannot equal 0, which we know that's not going to come into play, but let's just do this for fun, which means x cannot equal what? Yeah, pi over 2 and 3 pi over 2. Okay, next one. Now this is where it's a little bit more challenging because now we're really using our trig identities. So my advice to you is anytime you get stuck, look at your formula sheet. It probably has something in there. And anytime you change from 2 trig ratios to 1, it works, right, when you're solving. So does anybody see anything you could do here? This one's? Okay, so does everybody see the Pythagorean identity on your formula sheet? That secant squared theta is equal to tan squared theta plus 1. So I can replace secant squared alpha here. So I'm going to pull this out and write tan squared alpha plus 1 plus tan alpha equals 2. So it's one of the Pythagorean identities after sine squared plus cos squared theta equals 1. So what do we have to do first after we replace it? By the way, this is one mark of your solving, is replacing the trig identity with that. Just so you know. You need to multiply this in, yeah. So 2 tan squared alpha plus 2 plus tan alpha. I'm going to put minus 2 equals 0 because eventually I'm going to have to move that 2 over anyways. And at that point, what can I do? I can actually cancel these 2's though, the plus 2 minus 2. And yes, we can factor. What can we factor out now? A tan alpha, yeah. A tan alpha, and if I take a tan alpha out of the 2 remaining terms, what am I left with? Plus 1 and then equals 0, which means tan alpha equals 0 and negative 1/2. Okay, so at this point 0 is on the unit circle for an exact value, so what's alpha equal to? Where's tan 0? Okay, so tan alpha equal to negative 1/2 is not an exact value on your unit circle. So we're going to have to grab our calculator. And what is the process for finding the calculator portion of this? We ignore the sine, right, to get the reference angle. Make sure your calculator is in radians. Why does it have to be in radians? We're trying to find radians, it says. Okay, so from this one, we're going to get the reference alpha to be 0.4636. So you can save that or store that into your alpha A, whatever you want. But that's not our answer, though, right? Because tan isn't negative in the first quadrant. So how do I find where tan is negative? It's negative in the second and the fourth. So how do I find the second quadrant answer? Subtract that from pi. So pi minus that answer. So I get 2.6779. Yes? Okay, and what was the nice little thing about tan? That the other answer is always pi around. So if I take that 2.6779 and add pi, I'll get my other answer, which is 5.8195. I'm truncating at 4 decimals, yeah. It's correct to 3. There is a non-permissible value that we should probably be doing that at the beginning. So what's the non-permissible? Well, secant has a non-permissible and tan has a non-permissible, right?
Oh, right, it's 1 over.
Yeah, and actually they both end up being cos alpha, right? So cos alpha cannot equal 0, which means what? Alpha cannot equal, where is cos 0? Pi over 2 and 3 pi over 2, which that doesn't even come into play. But it's good practice. So if you're doing your homework tonight and you get an answer and you realize, and you look at the answer in the back and you don't get, understand why your answer is not there, check to see if it's a non-permissible that you should have rejected. Okay? Okay, next up. 2 cos squared x minus 3 sine x equals 0. So what should I do here first? Do like I did in the other one and do what? Look at my formula sheet and?
1 minus 7.
Yes, I can change this cos squared x into what? 1 minus sine squared x. Guaranteed question like this on the test. They always ask this on the exam. And you get your first mark in your solving just by doing this replacement here. Unlike the proofs, every time you replace something, you're only getting half marks. In a solving, this is a major concept for it. Okay, so next up, I need to multiply the 2 in. 2 minus 2 sine squared x minus 3 sine x equals 0. What should I do next? What should I do? We should never try to factor something that A is out of order and B is all negatives, especially for the square. So if I move everything over to the other side, it'll be all positive. So then this will be 2 sine squared x plus 3 sine x minus 2. Now this factors actually. So don't forget equals 0. So what is this factor to be? A 2 sine x and a sine x. And what else? Well, it has to be 2 and 1, so we just have to fool around with it. Yeah, minus 1 plus 2, because that'll give the positive 4 sine x and the minus 1 sine x to be positive 3. So that means sine x equals 1/2 and minus 2. And I can reject the minus 2 because sine x has to be between -1 and 1. Very good. Okay. So what does x equal then? Pi over 6 and 5 pi over 6. Very good. We remember all our values over the break. That's great. So I'm just going to move this out of the way. What are we going to do here? Do you guys want to try this one on your own? Yeah, let's talk about non-permissible values. Is there any?
Nothing there.
Cosine and sine do not have any non-permissible values because they don't have a denominator, right? What about the next one coming up? Is there non-permissibles here? No. So that's good.
There could be if you swap.
Yeah, I'm not. Okay, can I replace cos alpha with something? Not easily. Very good answer. Okay, what can I replace? Sine squared. You should always look for the squares because the squares are the ones with the Pythagorean identities, right? So 3 minus 3 cos alpha equals 2 bracket. Make sure you put the bracket and don't just write 1 minus. Do you see? Because it's the 2 times the thing you're replacing. So 1 minus cos squared alpha. Everybody see that? All righty. Multiply that in. So we get 3 minus 3 cos alpha equals 2 minus 2 cos squared alpha. What should I do next? Yeah, I'm going to move it to the left side. Why? Yeah, the square positive. So 2 cos squared alpha minus 3 cos alpha. If I move the 2 over, then I get plus 1 equals 0. So that factors. 2 cos alpha and a cos alpha. And what do we have to do with the signs there? Looks like they both have to be negative. So cos alpha equals 1/2 and positive 1, yes? Am I going too fast? Okay. Alpha equals, where's cos 1/2? A pi over 3, very good. And 5 pi over 3, very good. And where's cos 1? Sorry? 0 and 2 pi, very good. Okay, moving on. Rock and roll. Okay. Continue. How about this one? Cos 4x cos x plus sine 4x sine x equals 1. Ooh. It doesn't look very pretty, but does this look something? Ah, Looks like something on our formula sheet, doesn't it? Doesn't it look like cos alpha cos beta plus sine alpha sine beta? Yes? Kinda. And so what does that simplify to be? No, it's not sine A plus B. Cos alpha alpha minus beta. Look again at your formula sheet. Okay, so what's my alpha in this case? A 4x. And what's my beta? An x. So what does this simplify to be then, if I put it all together? Cos of 3x equals 1. Now, do you remember how to solve this? You could find cos of 2x, but then you'd be back to where you started with. This is why I have this handy-dandy little thing I called the happy face. Remember the happy face? Oh, you missed that class. Well, this is because everybody wants to divide by 3 right away, and I'm saying no, 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 no. It is attached. So the first thing you have to do is find where cos of happy face is equal to 1. So that means your happy face is equal to, I need to get my happy face here. Hold on. My happy face equals what? Where is cos 1? Not 0 pi, 2 pi. 0 and 2 pi. Now, the thing is this is 1 revolution, and if I'm going to be dividing by 3 in a second, that means my domain is going to be divided by 3. So what I recommended you to do is to do the k pi stuff here until you get to the final step, and then state all your answers from 0 to 2 pi. So what's another way of saying 0, 2 pi? What was the next one? 2k pi, very good. 2k pi, where k is an element of integers. Okay, so of course this is not happy face. This is where I get rid of my happy face. And what am I putting instead of my happy face there? 3x. 3x equals that. So what does x equal? I have to, yes, I have to divide by 3. So 2k pi divided by 3, where k is an element of integers. And of course, my domain does not say all real numbers here. The whole thing is divided by 3. It doesn't matter when you divide by 3, but anyways, therefore, x equals. So what am I going to start with my list for generating all the answers between 0 and 2 pi? 0. So if 0 goes in for k, what do I get? 0. If 1 goes into my k, what do I get? 2 pi over 3. If 2 goes into my k, what do I get? 4 pi over 3. If 3 goes in there, what do I get? You get 2 pi. Does everybody see you get 2 pi? Now, I could put the 2 pi, however, look at my domain. Am I supposed to have 2 pi in there? No. So you can either, this one you don't have to show a rejection. You can just not put it on there. So that's my final answer. All right. Pretty good. Move on. Okay, so what do you think we have to do here? Can I use the happy face method here because I got the 2x there? No, because I have an additional sine x, so that's not going to work. The happy face thing only worked because I had the 1. Like if you look at the previous example, I only had one thing equal to a trig ratio, right? So here I have 2 trig ratios. One's a sine of 2x and one's a sine x. So what can we do? Yes, anytime, if I haven't said this enough times, anytime you get stuck, look on your formula sheet and it'll guide you where to go. So there is a formula for sine of 2x. What is that? 2 sine x cos x plus sine x equals 0. Okay, what do we do next? factor out the sine x. Very good. And we're left with, how about 2 cos x plus 1 equals 0. So that means sine x equals 0 and cos x equals -1/2. It seems like we're getting the same things over and over again, hey? Is there any non-permissible values in this question? No. Okay, so where's sine x equal to 0? 0, pi, 2 pi. Where's cos x equal to -1/2? 2 pi over 3, very good. And 4 pi over 3, very good. All right, okay, next one. Cos 2x. Now, cos 2x has 3 formulas. Now, remember I said when we're doing things like the proofs and for the solving, it'll guide you of which one to pick. Now, which one should I pick? The only ones with signs in it, and that would be what, the third one, right? 1 minus 2 sine squared alpha, or in this case x. Does everybody see why I'm choosing that one? Okay, because I already have a sine x on this side. So 1 minus 2 sine squared x equals 1 minus 2 sine x. So now what do I do? Yeah, put it in quadratic form. I think I'm going to move it over to the right side so my square is positive. So I get 2 sine squared x minus 2 sine x. And when I move the 1 over, what happens to the 1? They cancel. So now how do I solve this? Actually, yeah, 2 sine x we can take out is the GCF. And so what am I left with? Sine x minus 1. So that means sine x equals? Yeah, 1, but it also equals 0. Yeah, 0 and 1. We get 0 from this one, right? Sine x. 2 sine x equals 0, so divide by 2, you get sine x equal to 0. Okay, so where's x equal? Zero pi, 2 pi. Where's sine x equal to 1? Pi over 2. Very good. Okay, look at that. Oh, we got one more. Woo! Just about done. We've been working hard here. Really hard. Okay. Who remembers what P of theta represents? It's a point on the unit circle. So what does that mean? What does 0.588 represent? Not just x. Cosine. This is my cos theta, right? And that one there is my sine theta. So this would be a calculator question because it's got decimals in it. But anyways, how would I figure out the coordinates of P of 2 theta? What would I have to do? Do I just double those? No. No, we would not. P of 2 theta would equal what coordinate? Not just x, y, but cos 2 theta, comma, sine 2 theta. Does everybody see that that would be the same thing? So, if P of theta is, so just think about this for a second. If P of theta is equal to cos theta, comma, sine theta, right? P of 2 theta would be cos of 2 theta, sine of 2 theta, right? It's kind of like saying, what's P of alpha equal to? Well, it would be cos of alpha, sine of alpha. Whatever's in that thing there, you're just replacing it, yeah. Okay, the problem is you can't just double these numbers to get cos of 2 theta, right? So, how do we do that? Well, we can use the formulas. It's all about the formulas. Like, so if you write the test or the exam and you haven't used the formulas, you're doing something wrong. This whole unit was on formulas, right? So, what's cos of 2 theta equal to? Yes, which one would you like to use?
So that's pretty much.
Which one's the pretty one? The second one? 1 minus 2 sine squared? Sure. 1 minus 2 sine, I'm going to write it out, okay? We're just going with this one just because somebody threw this one out there. It doesn't mean you have to use that one. You can use any of the three. So we are now going to be replacing sine of theta with 0.809. But we have to square that. Does everybody see? We're calling that sine squared theta is equal to sine theta, the whole thing squared. Yes? So we're going to punch this in our calculator. 1 subtract 2 times 0.809 squared. So we get negative 0.308962. Because this is an exact, well, not necessarily exact value, but I'm not rounding. What's wrong?
I use the different, I use the closed formula.
Yeah, but you should still get the same answer.
Yeah.
Okay. So what is sine 2 theta equal to? Well, there's only one formula for that. That would be 2 sine theta cos theta. So I'm going to substitute sine theta with 0.809 and cos theta with 0.588. And then I'm going to punch it in my calculator. And I get 0.951384. So, therefore, P of 2 theta is equal to negative 0.308962, comma, 0.951384. What quadrant is that in? Well, it's negative positive, so what quadrant is it in? Second quadrant. What did it start out to be in? So if an angle in the first gets doubled, would that sound correct that it would be in the second? Something like that. Well, if it's tripled, it could be in the second or the third. But I guess I'm just saying with common sense, if there's something in the first, now it could be a 20-degree angle and then you double that still in the first. I'm just saying having something in the first, doubling it, you wouldn't get negative, negative, right? You could have positive, positive still, or negative, positive, first or second it could be in, right?